This is a video for AQA Discrete Mathematics, Linear Programming Section 2.2, which introduces the idea of slack variables. This considers a linear programming problem which is fairly standard, where in this case we've got three variables, x, y and z. So we're asked to maximize, so this is our objective function, 5x plus 3y minus 8z, subject to the constraints that are given here, which are all inequalities. Now, the inequalities are okay from the point of view of the graphical method, but if you remember, when we did the graphs, to draw the lines, we would need equations. For the algebraic method, we will always need equations, so we need to turn these inequalities into equalities in some way. So to explain how we do that, just want to consider this little problem. So I've got 12 meters of cloth and I want to make some dresses and some skirts. A dress needs 3 meters and a skirt needs 2 meters of cloth. Well, we can, as usual, express this using variables. So if x is the number of dresses and y is the number of skirts, then we can write that 3x plus 2y must be less than or equal to 12. Obviously, we also have the constraints that x must be greater than or equal to 0 and y is greater than or equal to 0. We'll now consider that 12 meter of cloth laid out on a table, and there it is stretched out and going to be cut for 2 of the dresses and 1 of the skirts. So you can see that we've got 3 meters here, 3 and then 2, and at the end we've got some left over. An alternative to that would be to have 2 of the dresses and 2 skirts, and again there's a piece left over at the end. Now you can see that these pieces are always going to be greater than or equal to 0, and it's this part here that we refer to as the slack. So instead of writing 3x plus 2y is less than or equal to 12, which obviously it is, we write that 3x plus 2y plus the s is equal to 12. Now then, s is going to vary depending on the values or how many of x and y we have, but we can say that s is definitely greater than or equal to 0. Returning to the original problem, we've got 3 constraints here, which are non-trivial constraints, and we can turn those into equalities by saying the following. X minus y plus a slack variable, let's call it S1, must be equal to 1. X plus y plus S2 must be equal to 2. And 3x plus 2y plus S3 must be equal to 6. But we now have some extra trivial constraints, rather, that S1 must be greater than or equal to 0, S2 is greater than or equal to 0, and S3 is greater than or equal to 0. So we've turned the original problem, which had inequalities for the constraints, into this problem here, which has now got equations for these non-trivial constraints. And it's these equations that the simplex method goes about solving to maximize the profit function or the objective function, which is at the top. That's the end of this video. In the next one we'll see how we use these new equations to set up what's called a simplex tableau.